Yeah, good afternoon. Welcome to the class. Uh, I think, hello? Yeah. Am I audible? Okay, right. So I'm going to start the class. Uh, Today I'm going to start the introduction and the principle of introduction and the principles of chromatography. The lesson belongs to Unit 8, right? Now, this is the separation method to separate the compounds, separation of compounds in a sample. This method is useful for the separation of compounds present in the given sample mixture. Given sample mixture. It can be done either by chemical method or physical method. Generally, the separation process can be carried out by the chemical method or physical method. But here, this chromatographic method is the physical method. This method is called physical method. Chromatography are usually physical methods. Okay. But chemical methods are usually destruct the compounds, and sometimes it involves the decomposition, or sometimes the components are reacting together to produce the new molecule. Therefore, the desired separation will not happen sometimes by the chemical method. But in the case of physical methods, separation becomes separation becomes very easy when compared to the chemical methods. But only one disadvantage is the separation by using the chromatography is by using some chromatography method is uh, the quantity. Suppose if the bulk quantity of sample separation is not applicable because it is very difficult to separate them. It is involving a more amount of solvents and stationary phases and equipments. Therefore, the bulk separation is not possible by the chromatography. At that case, we need to identify the suitable chemical method. The suitable chemical method is the best method for the separation. But here, the chromatography is useful for the separation in the small scale. Okay, this is the actually uh, invented by the invented by the a botanist, it is the Russian botanist, Russian botanist. His name is Michael Sweat. The T is the silent Sweat. His name is the Michael Sweat. In the 1906, he used this technique to separate the pigments like chlorophyll, xanthophylls present in the plant material, green materials. Okay, present in the plant materials are separated by him by using the solutions of these compounds are passing through a glass column packed with the finely divided calcium carbonate powder. The separation species are appeared as a color band. So here he just used a vertical column, a glass tube. The glass tube is like this. Okay, it is fitted with a stop clock. The stop clock is inserted. Now this straight glass tube is filled with a fine divided calcium carbonate, calcium carbonate crystal, uh, calcium carbonate salt. Then, after filling this calcium carbonate, he just pass the solution of plant material. Plant material. Then, after passing this plant material, that is a liquid solution is passing through this, then it is eluted. It is eluted like a solute solvent droplets. Okay. Then, whatever the components present in the plant material, they will be appear as a color bands. They will be appeared as a color bands. The color bands like some these compounds are separated like a bands. Further, we are continuing the float of the solution. They will be executed one after eluted one after one. Right? These color bands on the column. These color bands on the column is a termed as the name chromatography. Right? By simply the compounds are separated as a color bands. Based on that, he named as a chromo. Chromo means color. Chromo means color. Color writing. Chromatography means color writing. After the Greek words chroma and graphene means chroma means a color and graphene is the writing respectively. Based on that, he named as chromatography. Chromatography. This is the history behind the invention of the chromatography. Right. The name chromatography now included a group of closely related separation methods and finds applications to both colored and colorless mixtures. Here, initially, the chromatography proposed by the test is used for the only colored compounds containing mixtures can be separated. But later, the same is applicable for the separation of the mixtures which are containing the colored compounds or colorless compounds. Okay, the applications of the chromatography is tremendously grown in the last 4 decades with the development of several new techniques intact because of such extensive applications of chromatographic techniques, as many as 12 Nobel Prize awards were given between 1937 to 1972 based on the works in which chromatography played in a vital role. Because by using chromatography, the separation method becomes very easier. So many organic compounds, so many metal complexes, so many compounds, organic or chemical, so many chemical compounds are separated from their mixture and characterized their properties and proposed their synthesis and discovered their synthesis. So many aspects of the studies are, uh, are, are reported based on the chromatographic methods. Okay. Chromatography has proven to have more advantages over other separation methods because it has a unique advantage. That is, the compound structure or compound property and compound geometry will not change. Therefore, this is the main advantage. Due to that reason, this is the more advantageous over the other separation methods. It has found wide applications in different fields of science like chemistry, biology, medicine, dyes, pharmacy, forensic pharmacy, and other forensic departments and clinical studies. Chromatography is thus a valuable tool for separation, purification, and identification of various compounds in a mixture. Next, some of the terms are involved in the chromatography. The terms which are involved in the chromatography are to be known to understand the principle and methods of the different chromatography. Okay. In that, first one is the chromatography. Already we have discussed this term, chromatography. What is chromatography? As per the IUPAC, IUPAC means International Union of Pure and Applied Chemistry, has defined chromatography as a method used primarily for the separation of components of a sample in which the components are distinguished between two phases of one of which is stationary phase. The distinguished phases are one of which is stationary phase, which is not move, or otherwise the stationary phase may be a solid or liquid, it will not be moved and supported on a solid or a gel. That stationary phase may be a solid or a gel or a liquid. And other phase is liquid or a gas, it will be moved through the stationary phase, right? That means one of which is stationary, while other one is moving. The one of the phase is stationary, that is the fixed, and the second one is the move. It will be moved. That is called, first one is the stationary phase, and second one is the mobile. Chromatography is also defined as a technique in which the components of a mixture are separated based on the rate at which they are carried through a stationary phase by a gaseous or liquid mobile phase. Once we are applying the chromatography method for the separation, the compound which are separated based on their movement or the interaction between the stationary phase and the compound and the interaction between the compound and mobile phase. That is playing important role. Based on that, we have defined chromatography is also defined as a technique in which the components of a mixture are separated based on the rates at which they are carried out through a stationary phase by a gaseous or liquid mobile phase. Next, second one is mobile phase. Chromatography, we have any method, it is having two phases. One is the stationary phase, and the second one is the mobile phase. Mobile phase. The stationary phase may be a solid or a liquid. If the liquid is the stationary phase, it will be used with a solid support. That means the liquid is binding with a solid, that will be taken as a more stationary phase. Next, mobile phase. The mobile phase is the liquid that is having the property to move, and the other one is gas. Right. Next. This is about the mobile phase and the stationary phase. Next, development. How the chromatography is developed. Development. Development. The process of separation of the sample compounds into a series of narrow waves zones, bands, or spots under the influence of mobile phase is called development. Suppose we are initially have shown the column chromatography by the test or sweat. This is the some column chromatography. Right. I have taken the stationary phase up to level is tagged with the stationary phase, and I am loaded the compound or sample mixture on the above the stationary phase. I just added mobile phase. This is the stationary phase. The stationary phase. This is the mobile phase. Now, whenever we are adding the stationary mobile phase, this will be moved from through the sample mixture and through the stationary phase. Once the mobile phase interacting with the sample mixture, it can dissolve. Then that will be traveled along with mobile phase. That will reaches to the stationary phase. Both the mobile phase and the sample mixture gets absorbed gets absorbed. Okay. Therefore, during the adsorption and desorption phenomena, mobile phase is moving along with the components present in the sample mixture, by which different adsorption and desorption strengths and the acting of capillary action, the compounds are separated out. Therefore, this phenomena is called development of development of chromatography. Therefore, the process of separation or the process of separating the sample compounds into a series of narrow waves. Series of narrow waves means a small bands will be generated like narrow waves, or zones may be some, these are the zones of the compounds may be separated, or some bands. Bands may be appeared like this. Some bands may be appeared, that may be, suppose that is the color compound, that may be appeared as a colored bands. Okay, or some spots. Similarly, in some other chromatography, that may be appeared like a two-dimensional chromatography, that may be appeared as a spots. Right? This is called the separation of the compounds from the mixture using the chromatography by moving the mobile phase through the stationary phase is called development. Next, chromatogram. Chromatogram in the case of HPLC and GC, generally we are used as the result is recorded on a paper, that is called chromatogram. Next term is chromatography. Just I want to change the color of pen. Yes. Right. Next, chromatogram. What is the chromatogram? After development of the chromatography, the resulted is presented either in the paper, either in the form of photograph, or either in the form of a graph. Is called chromatograph. Chromatograph. That is, if a detector, suppose in the manual or normal chromatography like the thin layer chromatography, paper chromatography, preparative chromatography, column chromatography, in this kind of chromatographic method, there is no separate chromatogram is not developed. Whatever the result appear on the instrument or equipment or glass operator, that is called chromatograph. But in the case of gas chromatography or a atomized chromatographic method like HPLC and GC, when the components are separated, that will be detected by the detector. After detecting of the compounds are recorded in the form of a two-dimensional graph. That may be a graph of bar graph or other continuous graph that is shown the amount of compounds or the percentage of the compound present in the given mixture. That presentation is called as chromatogram. The presentation is called chromatogram. Next, next term is elution. These are all important terms. We need to know for the understanding the all chromatographic method procedures. That is the elution. Elution means passing the mobile phase through the stationary phase and get exit from the that chromatography equipment or instrument or column. Right? That is called, that solution is called elution. After development, that is the mobile phase is passing through the sample and stationary phase. It carries the some of the compounds, some compounds along with them. Then the collected that solute solvent is called as elution. Then after development, the process of watching the bands, zones corresponding to the different sample components out of the stationary phase by addition of fresh mobile phase is called the elution. That means elution, and the solvent is called eluent. Whatever the solvent is came out from the chromatography instrument or equipment or the article, that is called eluent. Whatever the solvent came out. That is the elution is running of the development of the chromatography is called elution by passing the mobile phase. Right? Eluent is the whatever the solvent passed through the sample and stationary phase came out, that is called eluent. That is called eluent. Right. Next. The mobile phase used for elution is called as eluent or eluting agent. We can also call it as eluent or eluting agent. Eluent or eluting agent. Right. Generally, some of the other technologies commonly used in the chromatography are some terminology we have. Sometimes we shown with a chromatography is CC. The CC indicates the column chromatography. The name is column chromatography. Right. Next, GC. This indicates that gas chromatography. And GPC, a term. Generally, we see this one gel permeation chromatography. Next, LC, liquid chromatography. Generally, can call liquid chromatography. It is. And GLC, is sometimes this is also called as GLC. What is GLC? Gas liquid chromatography. Liquid liquid chromatography. Next, GBC. First GSC. You should know. Need to be known. GSC. GSC. GSC is gas solid chromatography. Solid is the stationary phase. Gas is the mobile phase. Solid chromatography. Next, GBC. GBC is the gas bonded phase chromatography. Phase chromatography. Next, HPLC. We can call it as in two ways. One is the high pressure, or this word also replaced with the high performance, high performance liquid chromatography. Liquid chromatography. And other one, another term, HPTLC. First, you need to know that what is TLC. TLC is the thin layer chromatography. Thin layer chromatography. All these terms, all these important methods we are going to learn in the next unit. Chromatography. Right. Next, HPTLC. That is high performance or high pressure liquid thin layer chromatography. High performance or pressure thin layer chromatography. Right. What is IEC? Next one is IEC, ion exchange chromatography. Ion exchange chromatography, IEC. Ion exchange chromatography. Next, liquid chromatography already we see. LLC, liquid chromatography. Liquid chromatography. Right. Next, LSC, liquid solid chromatography. Liquid solid chromatography. General column chromatography principle is also defined as liquid solid. Liquid solid chromatography. Next, LBC, liquid bonded phase. LBC, liquid bonded phase chromatography. Next, PC, paper chromatography. Paper chromatography. Okay, these are the several types of chromatographic methods are available for our field. Right? Next, classification of chromatography. Based on the several phenomena, we can classify the chromatographic methods. Next, coming to the classification of chromatographic methods. A variety of stationary phases and mobile phases are used in different systems. We have the different systems are there and different techniques are there. With all these different techniques, we can use variety of stationary phases and a variety of mobile phases. Based on that, chromatography method can be classified into different types depending upon the physical nature of stationary phase, physical state of the two phases, and mechanism of separation of the components. Based on the three ways, we can classify the chromatographic method. First one is the nature of the stationary phase, physical state of the two phases, and the third one is the mechanism of the separation of the components. Okay, first coming to the physical nature of stationary phase. The first way of classification is physical nature of physical nature of stationary phase. Based on this physical means by which the stationary phase and mobile phase are brought in contact with each other, all chromatographic methods can be basically classified into following two types. One is column chromatography, and the second one is planar chromatography. Planar chromatography. What is column chromatography? First, we come into the column chromatography. What is that column chromatography? In this type of chromatography, a stationary phase is packed in a long, narrow glass or metal tube. In generally column chromatography, we are using a vertical tube. A vertical tube already a twist or sweat used the chromatography. That kind of chromatography is called column chromatography. In that column chromatography, that means a long, narrow glass or metal tube. This is the long where you can use the long, narrow glass tube or a metal tube with the column. Just like a pipe. That pipe may be a metal pipe or a glass pipe. Right? Silicon glass pipe. That will be filled with a stationary phase that will be a solid. Right? glass narrowband, and the mobile phase is here is forced through. Mobile phase is the stationary phase, maybe a solid. Through that, mobile phase should be forced to pass through it. That suppose here in this case, a gravitational force is acting on the mobile phase that is passing through the stationary phase. That is the somewhat force by the gravity. Sometimes we may apply pressure, on the stationary phase by which a gravity force that is more than the gravity force. Therefore, that mobile phase is forcefully passing through the stationary phase. For such kind of for gravity force, that is called a simple column chromatography. By applying the gravity force, that is a simple column chromatography. Suppose if we are applying the force on the mobile phase, that is by forcefully we are pressing the mobile phase through the stationary phase. That is the applying force on mobile phase. For that example is gas liquid chromatography. We are applying the gas pressure on the liquid, right? That chromatography is liquid is the stationary phase, gas is the mobile phase. Here the liquid is bind on a solid surface. The liquid act as a stationary phase by which we are passing the gas. Therefore, the sample solution is passing through the stationary phase by which they are separated out. That chromatography is called as gas liquid chromatography and gas solid chromatography. Gas is the mobile phase, stationary phase is the solid. Therefore, gas is passing through the solid by which the carrier gas will be absorb the compounds present in the mixture and they can be easily separated from the mixture passing through the stationary phase. And other one, HPLC. HPLC is also example. And adsorption chromatography. Adsorption chromatography. Right? Next one is planar chromatography. Second type is the planar chromatography. What is the planar chromatography? We look at here, it is the pipe in nature. That is the three-dimensional space. Right? Three-dimensional space. Now, planar chromatography, planar chromatography planar chromatography, just like a two-dimensional chromatography. That means we are taking a paper for the running the chromatography, or we are using a thin layers plates for the chromatography. Such kind of chromatography is called as planar chromatography. That means this two-dimensional plane may be a paper or a thin plate, thin plate, right? Or a glass slide coated with stationary films, coated with stationary films. Example for this kind of chromatography is thin layer chromatography and HP high pressure thin layer chromatography and electro chromatography or electrophoresis also comes under this kind. Electrochromatography, it is. These are the two types based on the classification based on the physical nature of stationary phase. Physical nature of stationary phase. We can classify the chromatography in two ways. One is the column chromatography, another one is the planar chromatography. Next, coming to classification based on the physical state of two phases. Here we are using second type of classification is based on physical state of two phases. What are the two phases? Two phases. One is the mobile phase or moving phase, and second one is the stationary phase. Based on their physical state. Then the type of classification of chromatography methods in more fundamental. This is more fundamental classification. This is based on the physical state of mobile phase and stationary phase. That is, whether the mobile phase is liquid or gas, and whether the stationary phase is solid or liquid. Generally, stationary phase will not be a gas. Stationary phase will not be a gas, and mobile phase will not be a solid. Right? Based on that, this based on the physical state of stationary phase, it may be a liquid or solid, or mobile phase may be a liquid or gas. Depending on the physical nature of mobile phase, we have two general categories of the chromatographies. One is liquid chromatography, liquid chromatography. Another one is the gas chromatography. Gas chromatography, it is indicated with GC, right? First, coming to the liquid chromatography. What is LC? Liquid chromatography is the methods that are liquid as mobile phase. In this liquid chromatography, liquid is used as mobile phase. And liquid chromatography, example for the liquid chromatography is liquid chromatography, liquid solid chromatography. Liquid chromatography, liquid solid chromatography. These are the examples. Next, coming to the gas chromatography, the methods that employs gas as mobile phase are classified under gas chromatography. Whatever the chromatography which are involving gas as the mobile phase, those are classified under the gas chromatography. Example for the gas chromatography is GSC, gas solid chromatography, GC, gas liquid chromatography. Gas liquid chromatography. These are the example for the GC. Right. Depending upon the nature of stationary phase, whether the solid or liquid, we have different combinations of methods are there. Therefore, of classification classification of chromatography methods based on physical states of phases. Physical states of phases. Physical states of phases. I am going to give you a tabular form. I'm going to give you a tabular form. Right. In this tabular form, mobile phase is the liquid. The mobile phase is the liquid, and mobile phase is the gas. When the mobile phase is the liquid, that is called liquid chromatography. When the mobile phase is gas, that is called gas chromatography. And these are comes under liquid chromatography or LC liquid chromatography. GC means gas chromatography. Stationary phases. Whenever we are taking the mobile phase is the liquid, the stationary phase may be liquid as the adsorbed on the solid surface, and directly solid as the stationary phase, and ion exchange resin. Ion exchange resin generally used for the separation of the coordinated complexes or metal ions. Those are the charged species. Ions are we can use it as the separating stationary phase, separating agent as stationary phase. Okay. Ion exchange chromatography. Example for the ion exchange chromatography is separation of the metal ions from the metal resources solutions like calcium, nickel, um, zinc, right? This can magnesium. These are can be separated by the ionic exchange chromatography, and ion exchange chromatography can also use it for the purification of water, right, in the geolite process. Next, liquid in interaction of the polymeric solids. Okay, liquids are binding with the polymeric solids. Then the liquid is acting as a stationary phase, and another liquid can be used as the mobile phase. That is called liquid chromatography. Now coming to the gas chromatography, gas is the mobile phase, liquid is the mobile phase, sorry, stationary phase, which is adsorbed as the solid, and the second case is the solid is the stationary. Simple solid is the stationary phase. Therefore, in the first case, liquid is the mobile phase, sorry, stationary phase, gas is the mobile phase, that is called GLC, gas liquid chromatography, and gas is the mobile phase and solid is the stationary phase, that is called gas solid chromatography. Gas solid chromatography. Now coming to here we need to note that liquid chromatography can be performed on columns and on the phase surfaces, but the gas chromatography can be done only on column surfaces. Column surfaces, right? Next, mechanism of separation of components. Mechanism of separation of components. Right. What are the physical phenomena and chemical phenomena involved in the separation of the component? That can be explained. That method is that process is called mechanism. Mechanism of separation of components. Mechanism of separation of components. Right. The separation of components of a mixture depends upon the interaction of the components with the stationary phase. Separation of the components of a mixture depends upon the interaction of the components with the stationary phase. Mainly depends on interaction of components with the stationary phase. Okay. Depending upon the type of interaction, not only interaction, type of interaction also influences. Type of interaction, type of interaction. Okay, different chromatography methods can be classified on the following four types. Therefore, the chromatographies can also be again classified based on the interactions involved between the components and the stationary phase and the compounds and the liquid phase. Okay. Therefore, four types of chromatographies, chromatographic methods. The first one is adsorption chromatography, and the second one is partition chromatography. Third one is ion exchange chromatography. And fourth one is exclusion chromatography. Exclusion chromatography. Now, coming to adsorption, a simple one. Today I'm concluding with the adsorption spectroscopy, adsorption chromatography. Tomorrow we will discuss about the remaining two. Okay? Right. Adsorption chromatography. What is adsorption? Adsorption is absorbing the components on the surface of stationary phase. Okay, adsorption chromatography. The stationary phase is a solid and the mobile phase is a liquid or a gas. Therefore, solid is fixed as the stationary phase. The solid solute component or the components present in the mixture are adsorbed on the stationary phase, and the mobile phase is used to elute and separate the adsorbed components. We know that each components have the different adsorption strength with this stationary phase. Therefore, with the different adsorption strengths, the compounds are also adsorbed and dissolved by moving the mobile phase on the surface of stationary phase. Therefore, the strongly binded or strongly adsorbed compounds are move slowly, and weakly bind or weakly adsorbed compounds are moves with a greater velocity or speed. They can speedily move on the surface along with the mobile phase. Therefore, the compounds present in the mixture which are binds with the stationary phase. The compound which is strongly bind with the mobile stationary phase will be elute last. The compound which is weakly bind with the or weakly adsorbed on the surface of the stationary phase will elute first based on the strength of the adsorption of the components on the stationary phase. Therefore, in this technique, the solute components in the mixture are adsorbed on the stationary phase and